Hello and welcome to another tutorial. We are going to continue our discussion on creating objects, using objects, and what happens behind the scenes when we actually create objects. And we saw that when we create objects, we use the new operator in Java. And the beauty of Java is that they try to simplify a lot of complexities that was in C++, because they try to keep the syntax as close to C++ as possible, because in those days people were just using C++. So the new operator is the only way of creating objects in Java. And the way it works is that when you call the new operator, we saw that you call the new operator on a type. So you tell JVM, I want to create an object or an instance of this type. So in general, it has to be the fully qualified name. And we said that we use the import statements at the top of the source file, so that we remove the pain of typing the entire fully qualified name, especially if there are lots of packages and the package hierarchy is very long, right? And IDEs help a lot in terms of identifying which type, and they just automatically add the import statement. So, and we said what happens is that when we tell JVM to create a new object of this type, what happens here is that JVM searches the class path to find the type, right, based on the fully qualified name. Obviously, if it cannot find the type, it throws an exception, class not found exception, or class not def exception, something like that. But then the other thing is that if the JVM finds the type, it loads the class file into the memory, if that's the first time that you are accessing that type, right? The very first time you access a type, because every type has a class file, a separate class file associated with it. JVM loads that class file into memory so that JVM understands what type you're talking about, what are the attributes of that type, how many fields it has, how much memory that class needs, right? If JVM tries to create an instance of that type. So JVM has the meta information. It's called the meta information class file. When it loads into the memory, it's just a footprint of what are the attributes, how much memory this needs, the state of this class, how much memory it requires. And then when we say new operator, JVM allocates the memory on the Java heap, and then that memory is only reserved for the non-static part of the state of the object. We saw that a class by itself can have a state, which is defined based on the static variables or static fields. But when we use the new operator to create an instance, the amount of memory that is allocated by the new operator is not including that part of the static variables, right? Those static variables are not part of this memory allocation. They are stored separately somewhere called meta space. And the reason is that static fields, different objects of the same type, different instances, share the same variables, right? The static state has to be the same for all of them. And if any of the instances change this one of the static variables or changes the static state of the class, other variables have to immediately see that. But the variables or the fields that are part of the state of objects which are not static, each object gets its own unique copy. So if some object changes one of the non-static fields, other objects don't see any difference, right? They don't see that change because they don't share. The non-static state is not shared between different instances. So this new operator only allocates memory on the Java heap for the non-static part of the state of the object, okay? And then JVM knows based on the type and the number of parameters and the type of parameters that we are passing in the round brackets, which constructor to call. Now, if you're familiar with C++, you know that just writing the new point without any round brackets or anything actually calls a constructor, which is called the default constructor. And we saw that in Java, if you explicitly provide a constructor definition that takes parameter, the compiler doesn't add the default constructor. And that's the same behavior in C++, right? In C++ also, if you explicitly add a constructor, you don't get the default constructor which doesn't have any parameters. So you have to be careful about that. And then using objects, we saw that dot operators allows us to access the state of the objects, and we saw that the best practice is state is private, the fields are private. We define accessors like getters or mutators, which are setters. And the nice thing about getters is that when somebody says the object dot get and then the autocomplete feature of the IDE automatically shows you all the get method. So getters are good because then you decide which getter methods are public, right? Which means you allow user to read part of the state that you think is relevant for the user, right? You don't allow them to access all the state of the object, just part of them, which is useful. Now the next question is, okay, somebody's just creating objects obviously basically occupy memory because they have a state, right? Some objects actually don't have a state. Some classes are, which is mostly called utility classes, they all have static methods, for example. They don't have any fields or etc. Interfaces usually don't have any state. I mean, they're not allowed to have a state. Interfaces can have static fields, but static fields, again, is not part of the state of an object, right? It's just a state of the type itself. So abstract classes, for example, they still can have a state, but part of the methods, for example, has to be abstract. However, so as we allocate the objects and we create new objects to use them, right? We save some data in the state of a particular object, and then we use some methods to somehow either access the state or do something with that state, right? Do some calculations, etc. Now, sometimes we use an object and then do some calculations, but then, for example, the object goes out of the scope, and we've seen many examples. Let's go somewhere in one of the, for example, this Tesla class, or let's say we had the cars. Let's see. So when we create objects, if we saw that in a method, we can call the new operators, and then the reference to the object becomes, so when we create an object, for example, so let's go back. When we write this line of code, for example, point the name of the variable, which is of type reference, right, equals new operator, and then the type, and then the constructor. So the new operator always returns a reference of the same type. And we usually use this in a method or something, right? Every method has a local scope. Now the object is allocated on the Java heap, and regardless of which method you are in, there is only one Java heap, right? Now the key here is that the reference to that memory address, remember, we use this reference to access that part of memory that this object is allocated, right? The state is object resides on the Java heap, and we need this reference or the pointer. Remember, we said that references in Java are equivalent to handicapped pointers in C++. These are very handicapped. You can't do much with them, unlike pointers that you can do more in C++. Then references are handicapped pointers, which is fine. I mean, they hide a lot of complexities in Java so that the code is more readable and more easily understandable and maintainable, right? So, but if we use this line in a method, as soon as we go out of the scope of that method, this variable, which was a pointer to this object on the Java heap, right? This variable is stored on the stack frame of that method, and as soon as we go out of the scope of that method, the stack frame of the method is destroyed. This variable is destroyed. So this object, the data that it holds or the state, is still on the Java heap. But if we lose the pointer, if nobody is able to access that, then there is no point. I mean, that's not a valid object anymore because nobody can access it. So it's called garbage. And if we have garbage, then at some point that memory has to be reclaimed and cleaned up, right? Whenever you have a messy place, let's say Java heap is like a room and it gets messy, right? You create objects, it's like you throw some trash or something on the floor. If somebody is not using the object, then it becomes like a garbage, and somebody has to collect those garbage and compactify the memory, clean it up, make it nice and tidy so that allocating more objects becomes easier. And that's the job of garbage collector. And it's an automatic process in Java, so it hides a lot of complexities. Again, the whole point of Java is make life much easier for you so that you just focus on writing very nice code, very nice readable code and maintainable code, right? That's the motto of Java. Java says, I hide the complexity for you. You focus on writing very beautiful, very nice code, very nice maintainable code, and scalable, right? Java, the whole business of Java is to be able to write code that is very scalable. Now, Java doesn't promise to be fast. Java doesn't promise you that if you write a code, I make it fast. It's not the promise. Java promises maintainability and scalability. Obviously, if you want to really go fast, you have to go do C++ programming, which is not the topic that we're discussing here. So garbage collector, objects go out of the scope, nobody can access them, so the memory that they occupy, which means the state of that object, the data that object holds, is no longer useful to anyone because nobody can access them. So we have to clean it up. Why? Because memory is the most precious resource that your application has. And we say memory, it means volatile memory, or RAM, random access memory, the memory that the CPU interacts with. If you're familiar with the CPU, you know that there are a couple of level of memories that CPU can access. And why do CPUs need memory? Because the reason is that they do computations, but sometimes there are some intermediate data that the CPU needs, right? So CPU can't eat a lot of data at the same time. There is a limit. So it has to store some memory, some data, and then step by step consume part of the data until all the data is processed. So usually you have the data and you have your processor. The processor is just the CPU. The data is stored somewhere in the memory, and then CPU just reads the data one part at a time, processes them, and then spits out the results. That's the whole business of a processor. CPUs are extremely fast, but then reading the data from the memory is always the bottleneck that limits the speed of your application, right? And the problem with Java heap or the memory is that if the memory gets fragmented, which means we allocate the memory, usually the allocation requires some algorithm, right? Based on your runtime, or in this case for Java, it's Java virtual machine that determines which address at memory allocate that object. Then the idea here is that if the memory gets fragmented, which means we have a lot of garbage scattered in the Java heap, then you might request JVM to create a big object, but because of those fragmentations, that object doesn't really fit anywhere in the Java heap. It's a very, very rare occasion, because usually when you launch the JVM, there is a default amount of memory that JVM requests from the operating system. But anyway, garbage collection is important because not only your application might not run out of memory, you might still have memory in the Java heap. But because of the fragmentation, the garbages are all over the place, right? If somebody doesn't clean up the garbage, then the Java heap is fragmented so much that you can't really allocate object at a specific location because there is no enough room. So some object-oriented languages require that you keep track of all the objects you create and that you explicitly destroy them when they are no longer needed. And just like C++, right? Memory management is manual, right? Other programming languages, especially the ones that are called managed languages. Managed languages are the languages that have a virtual machine or a runtime that sits on top of your application. So your application doesn't directly deal with the hardware or operating system. It talks to a runtime, and the runtime talks to OS and CPU, memory, whatever. For example, Java has the Java virtual machine. Python has its own virtual machine that runs the Python code. Other other programming languages can also use their own runtimes, right? But for example, if you have a C++ program, you directly compile it to machine code, you run it, operating system allocates some resources, creates a process for that, and it's just your program directly talks to hardware, right? So, however, managed languages, you tolerate some penalty on the speed because everything you want to do has to go through your runtime and then to the hardware. You don't directly talk to the OS or the hardware. But at the same time, the virtual machine can provide a lot of automation in terms of, for example, memory management, garbage collector. So it's always a trade-off which way you want to go, right? Obviously, Java provides a nice trade-off in terms that Java provides some level of static compilation. It compiles to the bytecode, and then it still promises fast execution time. So Java has the JIT compiler, or just-in-time compiler. We will look at it in a more advanced lectures, but for now, the idea here is that memory is a precious resource, and there's always a concern that your application might run out of the memory if you just allocate objects, and never clean up your memory when objects become garbage. Now, in these days, for example, if you write a very simple Java application, but you can, at runtime, you can give the JVM a flag that, hey, use 1 terabyte of RAM as the initial Java heap. I mean, obviously, if you have a spare, you can spare like 1 terabyte of RAM to your Java application. In those cases, maybe garbage collection is not a big deal. It doesn't matter how many memory objects you allocate, because if your application just runs for like, I don't know, 5 minutes, 10 minutes, half an hour, it's not going to eat up all the 1 terabyte of RAM. So these days, memory has become very cheap. So the idea of garbage collection is not as big a deal as before. However, in enterprise applications, like let's say some company, a big company, tries to create a nice website for their users, and then they use Java, and then a lot of users should interact with it. So the application, the website has to be alive all the time, 24/7. So if you run a Java application that manages the backend, and application has to run for a long time without shutting down, right? Which means it just keeps consuming memory. And after a month or 2 months of running, maybe it runs out of the Java heap, right? So the idea is at some point you have to clean up all the garbage that is inside memory, so that your application has a better chance of utilizing much better Java heap. Now, the Java platform allows you to create as many objects as you want, limited, of course, by what your system can handle. And we saw this in the previous one of the previous examples that we talked about, new operator. We saw that obviously the runtime class in Java allows you to access some information at runtime about how many processors are available, what is your Java version, and how much memory you have requested from the so if you look at the print total memory, print free memory, you can get the runtime.free memory, and it returns the number of bytes that are free. So it can tell you what's going on. It can give you some insight into how much memory has been consumed, right? So as long as you have enough memory, you can allocate. So that's not a big deal. If the JVM runs out of memory, it tries to increase the amount of memory. And we saw that when you launch your application, there is also an attribute called max memory. And this is a hard limit that the JVM has to follow, which means if you really go out of memory, and then your JVM decides that your application requires more than this amount of maximum memory, JVM just crashes. It gives up. It just says, okay, I cannot go beyond this hard limit, so it just crashes with a out of memory error, for example. The Java platform allows you to create as many objects as you want, and you do not have to worry about destroying them, which means you do not need to manually figure out which object is not referenced anymore or is becoming garbage, and you don't need to manually call the delete operator. So in Java, there is no such thing as a delete operator. Obviously, in C++, there is a delete operator which calls the destructor. In Java, objects don't have a destructor. Some people argue that that was a bad decision, and then the whole mess of introducing finalizers, at some point finalizers got out of hand, and eventually they decided from JDK 9, let's just deprecate finalizers and remove it at some point. So maybe not adding destructors to Java classes was a bad decision, but still Java works, and this garbage collector business is still functional. So we'll just roll with it, right? The Java runtime environment deletes objects when it determines that they are no longer being used. This process is called garbage collection. Now, the key word here is that it says that it deletes the objects when it determines that they are no longer being used, which means the developer, the person who writes the source code, has no deterministic control on when an object is destroyed. It says that the Java runtime decides when to reclaim the memory or clean up the garbage. Now, this is all fine. It's fun and fine because then it removes the burden from the programmer's shoulders, right? And it's very nice. It's a very nice feature to have. The problem is that with this non-deterministic destruction of objects is that memory is not the only resource that an object might be using. I repeat this again. Memory is usually or sometimes is not the only resource that an object is using. What I mean is that an object might be dealing with handling files, opening a file, closing the file, right? And then usually what we want is that when an object opens the files, obviously we want that file to be open during the lifetime of that object. But then when the object is destroyed, we want that file to be closed, right? Because if the object is becoming garbage, nobody's using that object, there is no point of keeping that file open, right? So there are resources other than memory that the objects can acquire. And the question is, if we do not know when the object gets destroyed, then those resources are not freed deterministically. That's becoming the huge problem that we currently have in Java, right? That's why basically the idea was adding finalizers was to deal with this. They said that, okay, if an object acquires a resource, so let's go back to let's open up the object class from Java Lang. I'm going to open it up with JDK 16. So you see we have this finalize, and it's deprecated, right? So they're going to be removed. And you see in the notation, let me just open it up in the browser to see. Okay, why is it that we don't have access to? Let's see, where's the Java doc? So finalize can throw exception something. So deprecation, the finalization mechanism is inherently problematic. And again, they added this because somebody at some point when they created Java decided that they're not going to add distractors. Why? I think the original thinking was that distractors, which were part of the C++ objects, right, add complications. So they assume that people don't like distractors because it adds complexity, which, I mean, to some extent makes sense. The problem is that when they remove the concept of distractors for Java objects, the question was, there are two questions, right? How do we reclaim the memory that a object occupies the state of the object when it becomes garbage? And they added a automatic mechanism called garbage collection, right? But then there is one other question that they had to answer, and that was, what if the class acquires other resources, right? Resources other than memory. Then how do we free those when the class or the object becomes garbage? And they added this method finalize, which means if some class that inherits from object overrides this finalize method and it adds some code to it, then the garbage collector is informed when it goes to clean up the memory that object occupies. It is informed that, hey, this class has overridden the finalize, so you have to execute the code that is inside the finalize. So the garbage collector knows that it has to call the finalize method, right? Okay. Finalization can lead to performance issues. Obviously, if you put a lot of code in your finalize method and then the garbage collector it's mandatory for the garbage collector to call this finalize method. And obviously calling a method and waiting for it to complete takes time, and it gets worse if when the garbage collector calls the finalize, it actually throws an exception, the code inside the finalize. So it's very weird. If you're familiar with C++ distractors, you know that the distractors of the objects in C++ are not allowed to throw any exception, because that's disastrous, right? When you destroy an object, if the way the exceptions work, that as soon as an exception is thrown somewhere, you jump out of the stack frame of that method, and then you start doing a stack unwinding. So part of the code, if a distractor is allowed to throw an exception, part of the code in the distractor might not get executed, so the cleanup might not be successful. However, as you can see here, the declaration of the finalize allows the finalize method to throw exception, and that could be by itself problematic, right? So finalization can lead to performance issues, deadlocks, and hangs. Obviously, if the code in finalizer takes a lot of time, then you're in trouble. Errors in finalizers can lead to resource leaks. We will talk about what this means. There is no way to cancel finalization, because first of all, as a developer, when you write the code, you don't even know when the finalize method is going to be called, because destroying garbages in the memory and reclaiming the memory, basically the cleanup of the memory, which is done by the garbage collector, is automatic, and it is called indeterministic, which means you never know when it's going to be called. if it is no longer necessary, no ordering is specified among calls to finalize methods of different objects, right? So furthermore, there are no guarantees regarding the timing of finalization. Again, undeterministic destruction of the object. The finalize method might be called on a finalizable object only after an indefinite delay, if at all. Classes whose instances hold non-heap resources. Okay, so this is what I was talking about. Non-heap resource. So obviously a class, an object, when you create it, you acquire some resource, which is called the Java memory, right? And that's on the Java heap, right? So allocate memory to hold the state. That's a resource. Memory is a resource for any object. But again, objects might require or hold non-memory resources, like a file handle, right? An object might request operating system to give it a file handle so that it can read a file. And at some point, that file handle has to be closed, and the operating system has to be notified that, hey, we're no longer using that file handle, because operating systems do a bookkeeping, which means they keep track of how many applications are opening files, because operating system says, hey, I cannot allocate indefinite number of files to different applications or different processes that are running, because obviously two processes cannot access the same file simultaneously. That's disastrous. So if classes whose instances, or basically objects, hold non-heap resources, should provide a method to enable explicit release of those resources. And the Finalize was supposed to provide this explicit mechanism or deterministic mechanism, but again, it leads to a lot of bugs, errors. It's more problematic than being useful. Should provide a method to enable explicit release of those resources, and they should also implement AutoClosable. So this was the solution that the Java eventually came up with in JDK 8. AutoClosable. We will look at this later, but for now, AutoClosable is a marker interface. So if basically when you define a class, if you know that when you create an instance of that class is going to acquire some non-memory resources, then you mark it with AutoClosable. You say that this class implements AutoClosable, which means you're telling whoever using your code that AutoClosable is a strong hint to the user that, hey, this class is going to acquire some resources, and you have to explicitly close those resources. So don't rely on Finalizer. We're not using any code in the Finalizer to deal with those resources, but we are telling you beforehand that this class is marked with AutoClosable interface, which means you have to explicitly close. And you can probably guess that what's inside this AutoClosable interface. There is a method, there's an abstract method called close. And if a class is marked with AutoClosable, it has to override that abstract method close and provide the cleanup code for the non-heap resources. So the Java LangRef cleaner and Java LangRef phantom references provide more flexible and efficient ways to release resources when an object becomes unreachable. And again, same with, this is really not something that the normal Java developers deal with. But again, the same thing, if you have experience with C++, you realize that there are some references are basically pointers. At some point, somebody has to call the delete on those pointers so that the operating system knows that you're cleaning those resources, or operating system or the runtime of your application. Java, obviously, in Java, when your application runs, it doesn't directly interact with the operating system. Its runtime is JVM, right? So your JVM must know that your application is JVM has to know when to call delete, right? Called by the garbage collector on an object. So Finalize method is called by the garbage collector on an object when garbage collection determines that there are no more references to the object. This might not even happen during the lifetime of your application. Maybe you run your application, allocate a lot of memory, do a quick calculation, and after 5 minutes your application terminates. And the garbage collector determines that there is no point of cleaning up the memory because there was plenty of memory. A subclass overrides the Finalize method to dispose of system resources or perform other cleanups, right? The general contract of Finalize is that it is invoked if and when the Java virtual machine has determined that there is no longer any means by which this object can be accessed by any thread that has not yet died, except as a result of an action taken by the finalization of some other object or class which is ready to be finalized. The finalize method may take any action, including making this object available again to other threads. The usual purpose of finalize, however, is to perform cleanup action before the object is irrevocably discarded. And again, the issue with finalization is that memory management and resource management, resources other than memory, are supposed to be separate things. And the garbage collector that was implemented in Java was supposed to take care of memory collection, memory cleanup. But then the problem was that, okay, what if objects acquire other type of resources? What's going to happen? For example, the finalize method for an object that represents an input-output connection. And again, this is kind of like a resource. IO, file handles, these are kind of other types of resources other than memory, right? To break the connection before the object is permanently discarded. The finalize method of class object performs no special action. So if we look at the actual implementation of the finalize, it's empty. So the finalize method in the object class is empty body, but other classes can inherit from, obviously they inherit from the object class, and they can override this finalize method, right? It's a protected method. Protected means subclasses can access this and override it, right? It's not a private, it's also not public, which means other classes are not allowed to call the finalize method directly on a class, right? It's protected. Only subclasses can override, and the only mechanism that is allowed to call this is garbage collector, right? Now, this was a brief introduction to the garbage collector and the finalize method. In the next lecture, I'll show you how to override the finalize. Although it's deprecated and you shouldn't be overriding, but just for the sake of teaching, I'll show you how to do that, what happens when we override the finalize, and we can experiment with when the finalize is actually going to be called, etc. So please stay tuned, and I'll see you in the next one.